Let's delve into the short monitoring curve of an HPDC machine, which provides a visual representation of the important parameters we discussed earlier. By analyzing this curve, we can gain a deeper understanding of how each parameter impacts the short end process and the resulting casting quality. First, let's examine the pour hole velocity. This parameter is represented by the initial steep rise in the curve as the molten metal rapidly fills the die cavity. The steepness of this rise indicates the velocity at which the metal enters the cavity, with a steeper slope representing a higher pour hole velocity. Moving on to the slow short start position, it is reflected in the initial position of the curve before the rapid rise. The accuracy of the slow short start position is crucial to achieving proper metal flow and preventing defects. A precise positioning of the short start results in a smooth and consistent curve at the beginning. Next, we come to the slow to fast acceleration rate, which is represented by the slope of the curve during the initial rise. This slope indicates how quickly the short accelerates from a slow start to the desired velocity. A gradual and controlled slope signifies a well-optimized acceleration rate, ensuring uniform metal flow and minimizing turbulence. Now, let's focus on the gate velocity at the metal at gate position. This parameter is represented by the peak of the curve, indicating the highest velocity of the molten metal as it passes through the gate and enters the cavity. A higher peak represents a faster gate velocity, while a lower peak suggests a slower gate velocity. Similarly, the gate velocity at 90% fill is depicted by the position of the curve when it reaches 90% of its maximum height. This point indicates the velocity of the metal as the cavity fills up to 90% capacity. Analyzing the curve at this point helps us assess the uniformity and consistency of the filling process. Moving further along the curve, the impact pressure is represented by the peak pressure exerted by the molten metal as it fills the cavity. This parameter is indicated by the highest point on the vertical axis of the curve. The magnitude of this peak pressure impacts the overall casting quality and is critical to consider for defect prevention.